Let's go ahead and take a look at some quadratic expressions that have a leading coefficient that isn't 1. So let's take a look in this example at 6x squared plus 11x plus 4. Okay, now the way we approach this is going to be a little bit different, but the reasoning behind the scenes and what's going on behind the scenes is more or less the same. So what we're going to do is put a big X here, and here's going to be a plus sign, here's going to be a plus sign, and the reason we have plus and plus is because we have 6x squared plus 11x plus 4. So two plus signs here and here. Also the 6 is positive on here. That tells us everything is going to be positive, so put a plus sign here and a plus sign here. And we'll see variations on this in the upcoming examples. But anyway, what goes up here? Well, 6 splits up into 1 times 2 times 3. So that's what we put down there. What goes down here? 4 splits up into 1 times 2 times 2. Now what we want to do is multiply these guys together in some combination so that we have plus a number here, plus a number here, and this number plus this number gives us 11. So it's sort of like what we did before where the leading coefficient was 1. Okay, we found two numbers that multiply to the constant term here and add to get this term here on the x, or to get that number on the x. But here it's a little more complicated because we have something that isn't 1 on the x squared now. So the idea behind the scenes is pretty much the same, but it's a little more complicated now because we have a number here that isn't 1. So anyway, again, we want to find some combination here, multiply these numbers together to give us two different numbers in such a way that the one number plus the other number gives us 11 when we add them together. So let's see, what if we try 1 times 2 times 3? Well, 1 times 2 times 3 is 6, and down here 1 times 2 times 2 is 4. But 6 plus 4 is 10, which is not 11. Okay, we're looking for 11, remember that. And we're looking for 11 because that's what's on the x right here in the middle, positive 11. So that's not going to work, so we try something else. Now what if we try 1 times 2 times 2 times 2? Well, that gives us 8, right? And then, so we did 1 times 2 times 2 times 2. What's left over? A 1 and a 3. 1 times 3 is just 3. Does that work? Yeah, because 8 plus 3 is 11. So yeah, that actually does work. So plus 8 and plus 3. Okay, so now that we've done that, what do we do now? So there's still a little bit of work left to be done, so let's get rid of this so we can move on. So now we do have a few extra steps in between. So now that we have our 8 and 3, what we're going to do is say, okay, this equals 6x squared plus, now what we do is take the 11x and we split it up into 8x plus 3x. Okay, why 8x and 3x? Well, because here we have an 8, here we have a 3. Okay, so 11x becomes 8x plus 3x. And then we just still have the plus 4 out here. All right, now what do we do here? Now we go back to our old friend, factoring by grouping. So these two terms get grouped together. These two terms get grouped together, and we factor them separately. So 6x squared plus 8x, let's come off to the side down here. Let's maybe get rid of this right here. And we'll come off to the side down here. So 6x squared plus 8x. What's the greatest common factor here? GCF. So the greatest common factor between 6 and 8 is 2. The greatest common factor between x squared and x is just x. So if we pull out a 2x, what's going to be left? Well, 6x squared, if we factor out a 2x, what we're going to have left is 3x. Then we have plus 8x. If we factor out a 2x, what's left? 4. Plus 4. Okay, so that tells us then that 6x squared plus 8x is the same thing as 2x times the quantity 3x plus 4. Now what about here, this 3x plus 4 over here? Well, if we try to do the same thing, what's the greatest common factor? The greatest common factor between 3 and 4 is actually just 1. And here, the greatest common factor between x and no x is just 1 again. So the greatest common factor is 1 times 1, which is 1. which really means we can't really do anything here. So it's just the same thing as 1 times the quantity 3x plus 4. And that's exactly what we're going to put here. So if we go back up here, we're just going to have plus 1 times the quantity 3x plus 4. And remember, that's kind of what we want, right? Because remember, when we factor by grouping, what's in the parentheses here has to match what's in the parentheses here. So 3x plus 4 here means we ought to have a 3x plus 4 here. And we do. That's great. So now our last step in factoring by grouping is take this common factor here. So we have one whole term here, one whole term here. This term here has a factor of 3x plus 4. This term here has a factor of 3x plus 4. So there's a common factor of 3x plus 4 that we can pull out. And when we do, what we're going to have is the quantity 2x plus 1, okay, 2x, and then plus 1, times the quantity 3x plus 4. Okay? And that is the solution. So if we want to factor 6x squared plus 11x plus 4, then the result's going to be 2x plus 1 times the quantity 3x plus 4. Now, I just want to point out something real quick. You might be wondering, okay, we said plus 8 and plus 3, so that gave us plus 8x plus 3x, but could we not also have said plus 3 and plus 8, so that instead we have plus 3x and 8x? Or in other words, how do we know to group these two guys together and these two guys together? What if we had instead said 6x squared plus 3x plus 8x plus 4? Could we not have grouped these two together and these two together and factored like that? And the answer is actually yes, we could have done that. And if we did that, what would have happened? So we won't go through all the details, but we'll just real quick say what happened. So what's going to happen is 6x, so let's block this off here. So if we factor by grouping like this, then what we're going to end up with is 6x squared plus 3x becomes 3x times the quantity 2x plus 1. And then what happens over here, 8x and 4, we can pull out a common factor of 4, and we end up with 2x plus 1 left over. Okay, so notice here, when we did it this way, we had 2x times 3x plus 4 plus 1 times 3x plus 4. If we were to do it this way, we would end up with 3x times 2x plus 1 plus 4 times 2x plus 1. So notice there are some similarities there, right? Here's 2x, and then plus 1, and then 2x plus 1, 2x plus 1. Here's 3x plus 4 here, and here's a 3x, and here's our plus 4. Okay, so yes, when you factor quadratic expressions like this, eventually you do need to factor by grouping, and you could group like this, or you could swap these two terms around and group something like this. Okay, either way will work. It's totally fine either way. So anyway, 6x squared plus 11x plus 4 factors into 2x plus 1 times 3x plus 4.